Welcome to BKW Physics. I'm Mr. McConley, and we've been studying centripetal acceleration, centripetal force, and centripetal velocity. And I have a little demonstration based on that today. So, in its most basic sense, all this thing does is just a piece of wood, and so when the ball rolls, it just keeps the ball going around in a circle. So before we go any further, what is it that is keeping the ball going around in a circle? So basically, I am trying to, when I roll the ball, I'm trying to roll the ball straight. Okay, I go like this, straight. But the ball doesn't go straight. So what provides the impetus to make it keep turning?
The force of the wood.
The force of what?
The wood.
The wood. The wood is kind of like almost like a normal force. It's just not going to move in comparison to the ball. So it just keeps pushing in, whatever direction the force is, the ball will accelerate that way. In other words, it'll just keep curving. And we'll assume it's going at constant speed at this point. Thank you. So, what I want you to watch here is I'm going to let this thing go, and then I'm going to remove this piece. Can you see which direction it went from that point? Answer?
Straight out. Straight.
A little better answer? Tangent. Straight out is, yeah, I mean that's the idea, but the word you want to use is tangent. So when this is removed, this will continue to travel tangent to the point that the force could no longer act, because when the wood's removed, there's nothing to push, so it just is straight. What if you spun it? Someone always asks me that. What if you spin this thing? You spin it. You spin it this way. Is that going to make any difference? So when I remove this, if I spin it here and it's coming along, because I kind of like to spin it this way, it's just easier for me to spin it. If it's coming along this way, you predict that it's going to keep going straight even though it's spinning?
Yeah.
Let's see. I'll just remove it right away. Here we go.
Yeah.
Indeed it does. Okay? The spinning doesn't have much of an effect because there's not much friction on this. If this thing was more of like a rubber ball and you were spinning it, it would start to gain some friction, some traction, and it would probably spin and actually curve itself. It would curve like in an arc. But this thing has almost no friction, so when you spin it, it just acts like the same as if you rolled it. It just doesn't seem to make much of a difference. So for today, physics.